Today's lesson is going to be on solving one-step equations. In order to solve an equation, you must perform the inverse operation. And that's the same thing as the opposite operation. And so the opposite of addition would be subtraction. The opposite or inverse of multiplication would be division. So we're going to look at some examples of one-step equations. First, we're going to talk about equations where you would have to add or subtract. Let's say we have x plus 3 equals 7. Here, I see that my operation is addition. So I'm going to have to perform the inverse operation, which would be subtraction. I'm going to subtract 3 from both sides of the equation. I do that because they're equal. So if I subtract 3 from one side, I have to subtract 3 from the other side because these two sides are supposed to be equal to each other. Well, if I have a 3 and I subtract 3, that's going to cancel out and leave me with 0. So there's just going to be an x on the left side, and then 7 minus 3 is 4, so that I know that x is equal to 4. If you wanted to check it, you can just say that 4 plus 3 is equal to 7, and so you know that you perform this operation correctly. We can do another example with addition. Let's say we have a number first instead of the variable. So if I have 6 plus x equals 9. Okay, this is a positive 6. So in order to get rid of it, I would have to perform the opposite operation, which would be subtraction. So I would subtract 6 from both sides. A positive 6 minus 6 will give me 0. So I'm left with x equals 9 minus 6, which is 3. If I wanted to check this as well, I know that if x is 3, this means that 6 plus 3 is 9, and we know that that is correct. Let's try an example with subtraction. 5 equals x minus 2. Here we have subtraction in our equation. We know in order to solve this, we will have to do the opposite or the inverse operation, which would be addition. So I'm going to add 2 to both sides of this equation. A negative 2 and a positive 2 will cancel. I'll be left with x equals 5 plus 2, which is 7. X is equal to 7, or 7 is equal to x, however you prefer to write it. Either way, it's correct. I know that if I plug in 7 into the x, that would mean 7 minus 2 is equal to 5. We know that that is correct. And then let's do one more example with subtraction. Let's say I have negative 4 plus x equals 9. Okay? Here, I would also have to perform the opposite operation of subtraction, which would be addition. Since this negative 4 is here, I would have to add 4 to both sides. A negative 4 and a positive 4 cancel out. I'm left with x equals 9 plus 4 is 13. And if you remember from the previous video, if I want to add negative 4 plus 13, and I'll do an example of this. Let's see if I can erase this. Negative 4 plus 13. Remember, I have different signs, so that means I'm going to subtract and take the sign of the biggest number. 13 minus 4 gives me a 9. The 13 is the bigger number, So that means my answer is going to be positive. So that was correct, that x was equal to 13. And this is how you could check your work. The same way that you perform the inverse operations for addition and subtraction, you also do that for multiplying. So let's say 3 times x is equal to 18. 3x is multiplication, that's 3 times x. The inverse operation for multiplying is dividing. So I would have to divide both sides of the equation by 3. 3x divided by 3, the 3's cancel, I'm left with x. 18 divided by 3 is equal to 6. And if I wanted to check this out, I could go back to my original equation and say that 3 times 6 is 18, and I know that my solution is correct. Also, if you were dividing, let's say I have x divided by 4 equals 5. Here I'm dividing by 4. In order to figure out what x is, I will have to do the inverse operation. And the inverse of division is multiplication. I'm going to put this in parentheses because we know that parentheses mean to multiply. And I'm going to multiply both sides by 4. Well, if I multiply and divide by 4, I end up canceling out the 4's. I'm left with x equals 5 times 4, which is 20. If I want to check my answer, I can go back to the original equation, which was x divided by 4 equals 5. Well, I know that 20 divided by 4 equals 5, so my solution is correct. I'll do one more example of division, and then I will leave you to complete your whisk on your own. X divided by 3 equals 9. Once again, I have a division problem. In order to solve an equation that has division, we have to perform the inverse operation, which is multiplication. I will need to multiply both sides by 3. The reason why I'm multiplying by 3 and not 9 is because I want to get the x by itself. So I need to get rid of whatever is by the x. In this case, I need to get rid of this 3. I get rid of dividing 3 by multiplying by 3. That leaves me with x, which is what I was trying to solve for. 9 times 3 is 9 times 3 is 27. And if I want to check my answer, I go back to the original equation, which was x divided by 3 is 9, and I know that 27 divided by 3 is 9. So this is how you would solve one-step equation. Simply use the inverse operation.